Hello students, we are learning about weather and climate. Today we will learn about the atmospheric pressure and wind. Atmospheric pressure can be defined as the pressure of the column of air at one point on the earth's surface. That means the air above us that exerting a weight on our earth's surface. That is the atmospheric pressure. Atmospheric pressure depends on some factors like altitude, temperature, moisture content, and rotation of the earth. Altitude means height of a place. When the altitude increases, pressure decreases because the air becomes thinner or less dense. When the temperature increases, pressure decreases because hot air expands and rises up. Because of that, the density of air decreases. The molecules of the air that will be expanding, and because of that, it is having only less weight. On the other hand, where the air is cooler, the air molecules contract and they have more density, so they will sink to the earth's surface. That makes the area high pressure zones. Moisture content means the presence of water vapor. Wet air which is having more water vapor. That means water vapor replaces the oxygen. Oxygen is a denser air molecule. On the other hand, water vapor is having less density. So when oxygen is replaced by the water vapor, the wet air or humid air or the moist air becomes low denser than the dry air. Rotation of the earth also influence the atmospheric pressure. Rotation that deflect the wind, and this causes piling up of air that leads to the formation of high pressure zones. Sometimes the rotation that scatters the air that can lead to the formation of low pressure regions. Low pressure is usually associated with the stormy weather because it causes inflow of winds from surrounding high pressure areas. Occurrence of cyclone is related with a low pressure. High pressure, that means calm and fair weather because air sinks and gets compressed in the high pressure regions. Atmospheric pressure can be measured with the help of barometers. There are two types of barometers. Here, this is the diagram of Mercury Barometer. So, in this barometer, mercury is used for measuring the atmospheric pressure. So, here there is one vessel, there mercury is filled, and one test tube that is inverted down into that mercury vessel. So, here the mercury that is filled in the test tube also. So we know that the atmospheric pressure, when it is increases, it exerts a weight over the mercury column. So that time this mercury, it will go upward in the test tube. When the pressure decreases, this mercury will come back and spread in the vessel. That is the method of working of this mercury barometer. So here this level that shows the average or mean sea level, the average atmospheric pressure that is shown by 76 centimeter of the mercury column in this test tube. That is the average sea level atmospheric pressure condition. When the pressure increases, the mercury level will go above 76 centimeter. When the pressure decreases, the mercury level will come downwards. That means it will be below 76 centimeter. Actually, this mercury barometer, it is very difficult to carry around. This is the Aniroid barometer which is used to measure the atmospheric pressure. It is used by travelers and explorers, and it is the nowadays it is the most commonly used barometer because there is no liquid used. It is easily portable, and this instrument, it shows the atmospheric pressure in millibars. That means the measuring unit of the atmospheric pressure is millibar or MB, that is the short form. And in the average sea level, atmospheric pressure will be approximately 1013 millibar. 1013 millibar, that is the approximate atmospheric pressure in the sea level. If the pressure increases, the atmospheric pressure will be measured above 1013 millibar, and if the pressure decreases, the atmospheric pressure will be go below 1013 millibars. Now we can learn the working of an Aniroid barometer. This is made up of one thin metal box. Inside the thin metal box you can find a vacuum chamber. It is made of thin metallic substance which will fluctuate in its shape according to the pressure changes. When the pressure increases, the air exerts a weight over the vacuum chamber. That fluctuations will be marked over the lever. Means movement of the lever takes place, that moves the spindle, and the movement of the spindle will be marked by the pointer. When the pressure decreases, that time this vacuum chamber it will release. That movements also will lead to the movement of lever and spindle, and pressure changes will be marked by the pointer. Wind is the next element of weather and climate. It is the horizontal movement of air. Wind is always guided by the distribution of atmospheric pressure. Wind moves from high pressure region to low pressure region. It is influenced by the rotation of the earth. Rotation of the earth generates a force which is known as Coriolis force. This deflects the wind in both the hemispheres. In the northern hemisphere, wind will deflect towards the right of its path, and in southern hemisphere, wind will deflect to the left of its path. Wind velocity depends on the difference between high and low pressure. High speed winds will blow when there is too much difference between the pressure belts. Speed of the wind is less when the difference in pressure is less. Winds modify the weather of a place. Warm winds makes the place warmer. Cold winds decrease the temperature of a place, and moist winds bring rainfall to a place. Windvane, that is the instrument used to determine the direction of a wind. Here this part of this instrument that's showing the wind vane. So here this is the pointer. It is mounted on a pole, and it will be able to rotate freely according to the movement of the wind, and this pointer will show the direction of the wind from which direction it blows. So here you can find the fixed markers that showing the cardinal directions: north, east, south and west. So here the wind is moving from the south direction. Towards the south the pointer is pointing. So the wind is coming from south and moving towards the north direction. That means the winds, they are named after the direction from where they are originating. So the wind that coming from the west, they are named as westerlies. The wind coming from the south, they are named as southerlies. Okay. This instrument, it is a combined instrument which is having an anemometer which is used for measuring the speed or velocity of the wind, and also a wind vane. So here you can see this part, it is showing the anemometer. Here semicircular cups are arranged on a pole. So this will be rotating according to the speed of the wind. So here the wind that lead to the movement or rotation of these cups, and that is attached to a meter at the base. At the base there will be a meter, and that will record the spinning movement of the cups. So that spins, that will show the speed of the wind. That the unit is kilometer per hour, otherwise knots. Kilometer per hour or knots.